A paraplegic man made the first kick of the World Cup in Brazil. Another paralyzed man walked down the aisle with the love of his life, all thanks to robotic structures called exoskeletons. Exoskeletons can be used as a means of rehabilitation or can be replacements for people who have lost their arms. Industrial workers, dock workers, loaders, and medical workers who are engaged in jobs which entail lifting heavy loads on a daily basis are empowered by the exoskeleton, helping them in their job and reducing chances of work-related accidents that could cause long-term problems like chronic back pains. Exoskeletons are wearable machines or motorized muscles that help multiply the wearer's strength. In the medical department, these exoskeletons are tools for rehabilitation as they help restore human performance or even offer a new limb for amputees. They mostly serve as a tool to support, assist, lift, or even stabilize the patient. These exoskeletons are powered and equipped with sensors and chips. Thanks to these fascinating machines, paralyzed patients have the opportunity to walk again, amputees can replace their lost limbs, and some exoskeletons even offer the ability to feel the sensation of touch. For the purpose of this study, we are going to focus on the different fields involved in creating mind-controlled exoskeleton arms for amputees. The main difficulty when creating mind-controlled prosthetics is detecting and generating peripheral nerve signals, which are infinitely small. Neuroscientists offer the skills and knowledge to connect these nerves to a piece of muscle in order to amplify the neural signal as it is converted into a much bigger muscle signal. An array of chips and electrodes are surgically implanted into the arm of the patient, allowing us to successfully record and control neural signals. All it takes is thinking about moving the hand for the prosthetic arm to move accordingly. This product doesn't require much effort from the patient, all thanks to the engineering behind. Computer and mechanical engineers collaborate to find smaller, more powerful system components, as well as biocompatible implants and light, durable materials. The mechanical engineer's job is usually focused on calculating the appropriate force to grasp an object, depending on size and weight, while computer engineers will work on choosing suitable sensors, chips, electrodes, and algorithms for the arm to function properly. They are also in charge of translating neural activity into control signals. Hence, such a discovery has only become possible thanks to the combination of these two areas of research, medicine and engineering.
This project could drastically improve the lives of people who have lost a limb or need rehabilitation and enhance the lives of people who must deal with heavy lifting or other activities in a goal to improve the quality of life of mankind. Thanks to the beneficial advances of technology, engineers are finding new effective ways to read and control neural signals without going through surgery. Hence, in the near future, this project will no longer require neuroscientists. However, for the time being, these techniques still need improvement and neuroscientists remain essential for this engineering project. Despite exoskeleton arms being a breakthrough in engineering, there are several limitations to them. One of the main reasons why exoskeleton arms aren't widely accessible is their price. Starting from $40,000, prices for exoskeleton arms go up to $120,000, depending on the weight of the device and the technologies used behind it. Moreover, exoskeleton arms are heavy due to the materials used in their design. All the heavy materials can be replaced with aluminum and 3D printed carbon fiber. Some fasteners, sensors, and motor shafts cannot be replaced with plastic. For disabled patients, it can be very difficult to manage the weight of an exoskeleton arm as it requires increased effort and strength to carry and move. Exoskeleton arms lack the ability to adapt to a person's specific arm structure and anatomy, which impedes the rehabilitation process. For example, an exoskeleton arm can rotate your joint without including it. This, in turn, will cause serious trauma. Overall, the exoskeleton arm is a beneficial technology that can be advanced to minimize the discrepancies using the newest methods in science and engineering. Helping the arm to rehabilitate more effectively, exoskeleton arms are a much more effective way of recovery as opposed to traditional medicine.